Hello all, I'm Gajen Singh from IIT Bombay. So here is our next question, which is again based on the pulley and object string type questions. So in such type of questions, the important thing will be given that this pulley will always be frictionless. So we are solving for the frictionless pulley and these strings are inextensible. Okay, so what's the question? That there is a frictionless pulley over which these objects of masses m1 and m2 are suspended through a light inextensible string. Now, as I've already explained in the previous videos how to solve these type of questions, first we have to determine all the forces. Now, if there are two objects, so obviously their weight will act in vertically downward direction. So let this weight be m1g. And the weight of object of mass m2 will be m2g. Now one more thing, that whenever an object is attached here, so obviously the tension will be developed, and as we have already discussed in the previous video, that tension is always directed away from the object. So this is our object, away from the object. So tension, this is our tension. And one more thing we have discussed, that if there is one string, so one string, one tension. So even this will be T. Okay. So now what to do now? So if we consider the object M1, object of mass M1. So for M1, this vertical forces, as we have discussed, that first we should consider the system to be in equilibrium. So for vertical forces, if we of mass m1, this is T is equal to m1g, and for m2, T is equal to m2g. This is only for the case when the system is at equilibrium. Now suppose in the question, mostly in such type of questions, you will have to determine the acceleration of the system. So first, for determining the acceleration, we should first know that in which direction this object is going to move. Now if you see here, we are neither given the value of m1 or m2. So in such a case, don't worry, just predict any of the direction. So we are predicting that this object is moving upward. The object of mass m1 is moving upward. So if this moves upward, obviously m2 will move downwards with acceleration a. Don't worry about the direction. Even if in question, if your predicted direction is wrong, then your answer will be negative. So just convert it to positive, and then you will be knowing that okay, the direction was opposite to that which we have assumed. So okay, so now let's again focus on this, that this equation stand valid only if the system is at equilibrium. Now as we have assumed that this object of mass m1 is moving upward and object of mass m2 is moving downward, consider this first object. So now there are total three forces, this m1g, the T, and if it is accelerating, then m1 into a. So for m1, here the two forces in the here are T and m1g. Now since the object is moving upward, the upward force should be greater. So therefore we are taking T minus m1g equal to m1a. Now for those who didn't get this equation, please check onto our previous videos. So opposite direction minus, then since the object is moving upward, the upward force should be greater, therefore we are writing T here first. Now for m2, this object is moving downward, so the downward force should be greater. m2g minus T equal to acceleration, so therefore m2 into a. Now, since we have been asked to find the acceleration, just solve this equation simultaneously. Add 1 and 2. So equation 1 plus equation 2, t minus t cancelled. Here g common. So here it's m2 minus m1 equal to, here acceleration common, m1 plus m2. So therefore acceleration is m1. Sorry. The equation for acceleration turns out to be now m2 minus m1 into g upon m2 plus m1. So this is the final equation. Now, if in the question suppose acceleration is given and if you have to find tension, so now first like use these equations, acceleration will be given, mass is given, then obviously you can find the tension as well. So that's it for today. I hope you like the video. If you have any doubt regarding this question, so please ping us on getjwneetqa@gmail.com. The link will be given in the description. The link for the previous videos will also be given in the description. Thank you.